So if you're building anything with a large language model, you have almost certainly hit the same wall that all of us have: testing. Honestly, it's one of the biggest headaches in AI today. So let's dive in and explore a much smarter way to make sure your LLM is actually correct.
And yeah, this is really the million-dollar question, isn't it? We're so used to a normal software where you put something in and you get the exact same thing out every time. It's predictable. But LLMs, they're a totally different animal. They're literally designed to be creative, to be variable. So how in the world do you build a reliable test for that?
All right, here's our game plan for today. We're going to start by really nailing down the core problem and see why the old ways of doing things just don't work anymore. Then I'll walk you through a really powerful solution called the hybrid pipeline. We'll cover how to build its foundation, the golden dataset, and how to train its AI referee. And we'll wrap it all up with 4 simple rules to make sure you succeed.
Okay, let's get right into it. Why do those traditional testing methods completely fall apart here? Well, there are a few common ways people are trying to test their models. But as we're about to see, each one, when you use it by itself, has a massive, and I mean massive, blind spot. So you've really got 3 main options. You can have humans check everything by hand, which is, super slow and costs a fortune. You can use something called vector comparison, which tries to see if the meaning of 2 answers is the same. Or you can use another AI to grade the first one, which we call LLM-as-a-Judge. The trouble is, manual work just doesn't scale, and the 2 automated methods can be wildly off in completely opposite directions.
Let's look at a real example to make this concrete. We've got 2 answers from an insurance bot. On the left, that's our perfect fact-checked reference answer. On the right is what our LLM produced. Now just look at them. They seem almost identical, right? Same list of documents, same application methods, but look closely at that highlighted text. There's a tiny change in wording that makes a huge difference. Because these 2 answers are so similar on the surface, a vector comparison test looks at them and says, yep, the meaning is basically the same, and gives it a really high similarity score. So this should be a pass, right? The test says it's good. But is the answer actually correct? Nope, not even close. Buried in that generated answer is one tiny but absolutely critical factual mistake. The correct answer says the term is fixed at 1 year. The LLM's answer just made up the fact that you can choose the term. Vector comparison completely missed it because that one wrong detail was just drowned out by all the other correct information around it. And that, right there, is its biggest weakness. Now, on the complete other end of the spectrum, you've got the LLM-as-a-Judge. And this one can have the exact opposite problem. It might fail a perfectly good answer just because the phrasing is a little different. It gets way too hung up on tiny wording changes that, from a business perspective, make zero difference to the quality of the answer. So if one method is basically blind to details and the other one is way too sensitive, what do? Well, you don't pick one. You combine them. You build a hybrid pipeline that uses the strengths of each method to cancel out the weaknesses of the other. It's actually a pretty elegant solution. And the logic here is really clever. First, you run both tests on every answer. Now, if they both agree, if they both say pass, or they both say fail, great, you can trust that result and automate it. But the magic, the real secret sauce, is when they disagree. That's your signal. That specific case where one passes and the other fails, that's what you flag for a human to review. This cuts down your manual work like crazy while catching all those tricky edge cases.
Okay, an automated pipeline sounds fantastic. But for any of this to work, for any of it to mean anything, it has to be grounded in reality. It needs a source of truth. And that brings us to what is, without a doubt, the single most important piece of this entire puzzle: your golden dataset.
And I know what you're thinking, because it's a tempting shortcut. Creating a really good set of perfect questions and answers takes time and effort. People might push back and ask, can't we just, skip it and just check if the right tool was used or something?
Let me be as clear as I possibly can be. No, absolutely not. Your golden dataset, that collection of perfect reference answers, is completely non-negotiable. It is the bedrock. It's the anchor for your entire testing strategy. If you don't have it, you are flying completely blind.
So why is it so non-negotiable? Well, think about it. It's the only way you can tell if a new change you made accidentally broke something that used to work.
That's called regression. It's also the only way to be sure that your model's answers are actually complete. And maybe most importantly, it's a stable benchmark. Even if you totally rewrite your prompts or change the tools your system uses, your golden dataset is still the ground truth that you measure everything against. So, we have our ground truth, the golden dataset, and we have our smart hybrid logic. Now, let's zoom in on that one component, the LLM as a judge. How do we make sure it's actually being a fair and effective referee? To get this right, we're actually going to borrow a little wisdom from, of all people, Sheldon Cooper. He once famously argued that there are no degrees of being wrong. You either are wrong or you aren't. And for what we're doing here, he was 100% correct. This leads us to something called binary scoring. It's simple. The judge does not give partial credit. An answer is either a 1, meaning all the facts are 100% correct, or it's a 0. That's it. An answer that gets 3 out of 4 facts right is still a 0, because let's be honest, from a business perspective, a partially wrong answer is just a wrong answer. This makes finding your errors so much easier. And here's a really important detail. The judge has one job and one job only. It checks for factual consistency against the golden answer. Is the information correct? Yes or no? That's it. All the other stuff, like tone of voice, politeness, brand guidelines, that needs to be tested in a completely separate process. Don't confuse the judge by asking it to do too many things at once. Okay, we've got the strategy, we've got the components. Now let's bring it all home. Let's talk about the playbook. 4 simple, super practical rules to make this whole thing work in the real world. First up, rule number 1, version everything. And I mean everything. Your benchmark questions, your reference answers, even the company policies those answers are based on. Why? Because facts change over time. An answer that was perfect yesterday could be wrong or even a compliance risk today. Versioning is the only way you can reliably track changes and avoid testing against old info. Rule number 2, calculate the cost. You've got to remember, every single test run, especially that LLM-as-a-Judge step, is making API calls. It's using compute time. It costs real money. You need to figure out your testing budget. And this isn't just about saving a few bucks. It forces you to be smart, to find the most efficient models that give you the quality you need for the lowest price. All right, rule number 3 is a fascinating one. Don't bribe the judge. Now, what does that mean? Well, research has shown that LLMs have a bias. They tend to give higher ratings to answers generated by their own family of models. So, to get an objective score, you need to use a judge from a different family. If your app uses a llama model, use something like Claude or GPT to be the judge. It keeps things honest. And finally, rule number 4. This is the one you need to take back to your team, to your boss. Demand the benchmark. Make the creation of that high-quality golden data set a mandatory, non-negotiable part of the project plan. If someone gives you a list of requirements for an AI but no benchmark to test against, you don't really have requirements. The benchmark is the contract that makes everything else real. So there you have it. It's pretty easy to make an LLM look smart and sound confident. That's the easy part. But the real question, the one that actually matters, is whether it's factually correct. And with a hybrid pipeline anchored by a solid golden dataset, now you actually know how to find out.